and then I'll see if I can upload it for the people who couldn't be live today. Okay, well that didn't say anything, but am I recording? Yes. Okay, so I'm going to share the screen again to go over the lecture on immunization. Okay, can you see that all right?
Yes, looks
so immunization is also known as asset liability matching. And it's actually something that actuaries work on quite a bit. And I always say that I was at a bit of a disadvantage when I started as an actuary because I never took any business classes. So you have to do asset liability matching, which is very important for a company. And I didn't know what an asset or a liability was. So now that we make actuaries take finance classes, you won't be in that same predicament. So the goal, and this is another use of duration and convexity. Remember we studied that and we used that to estimate what the price of a cash flows do when the interest rates change. And so changing interest rates affect companies' surplus quite a bit. So the basic accounting equation, if you don't remember, the surplus is equal to assets minus liabilities. And since assets and liabilities are usually future cash flows, technically the surplus is the present value of assets minus the present value of liabilities. And therefore, since it's present value, surplus is a function of interest rates. And as interest rates move, surplus will change. So if you have a function of, surplus is a function of I, if I changes, the surplus changes. And you don't want to have interest rates ruin the company's surplus. And so the process of immunization is you're trying to protect the company's surplus against adverse deviations caused by interest rate movements.
Good question.
Yes.
So when you talk about surplus, because doing accounting, it's, you know, assets equals liabilities plus owner's equity. So when you're talking about surplus, do you mean like the increase of the owner's equity through income?
Yes. Surplus is the same as E in accounting. So yeah, in accounting, it's assets minus liabilities equals equity. Yeah, good question. Equity and surplus is the same.
Why do they term it surplus? What if it's not a surplus? What if it's actually a deficit?
Oh, you can have negative surplus and then you'll be bankrupt. The state will take you over.
Okay, thanks.
So yeah, you want to make sure your assets exceed liabilities. And so the company will usually have a positive surplus just because, you know, since it's equity, someone has put money into the company. So it would take a lot to blow through all of the paid in surplus is what it's called. And yeah, you can think of this as equity. They're interchangeable. It's just usually called surplus at insurance companies and probably all companies. So here's a very contrived example, as most examples are. Suppose the company has a single liability of paying $100 5 years from now, and they have an asset or two assets, one that pays $66.15 1 year from now, and one that pays $31.72 20 years from now. Let's say that current interest rate environment is 8%. Well, if we calculate the present value of the $100, you get $68.06. And if you calculate the present value of the assets, you get $68.06. That's why we picked those two numbers. So if the interest rate is 0.08, the surplus in this example is 0. But if interest rates drop by 2% down to 6, and we redo that calculation, so we're just changing the 8 to a 6, we see that the assets shrink more than the liability, or grow by more than the liabilities. They both increase because the interest rate dropped. So now we have a negative surplus. Or you can think of it as a negative impact on surplus rather than a negative surplus. So whatever this added 0, and now it's adding a negative. So you want to match your liability, your assets, so they can match the liabilities. And there's 3 types of immunization you need to know for Exam FM, or if this is Finance 415, if you're watching it on YouTube, what you need to know for Finance 415. The first one that's not very practical is called cash flow matching. It's also known as dedication. It's also known as absolute matching. The second one is Redington immunization, named after a very famous actuary in the 1800s named Redington, or maybe the early 1900s. And then full immunization. So just remember there's 3 types you need to know. On the exam, usually the quantitative problem solving are from categories A and B. I think this is the first topic where you actually have some conceptual definition questions, and often the full immunization are of that type, although you can get some calculation for full immunization. So what do each of these mean? Well, for A, we want the asset cash flows to exactly match the liability cash flows. So if you're trying to protect your assets, if you're trying to protect your surplus from moving with the interest rates, if for every dollar of liability at that time the liability is due, if you have an exact cash flow that matches it, then you don't have any risk. The assets and liabilities will just move in tandem, and the effect on surplus will always be 0, no matter what interest rates do. And just say, by the way, liabilities result from products that are sold. So if you sell an insurance contract, the liabilities are the future death benefits. If you sell an annuity, the future benefits are the annuity payments. If you sell a pension, it's going to be pension payouts. So a company has no choice as to the timing or the amount of the liability cash flows, but the assets are what the company buys. So in all the problems, the liabilities will be given, and then as the actuary, you have to choose the assets to match the liabilities. So keep that in mind. That's the liabilities that are given, they can't be changed, but the assets can be. And so you get to work a lot with the investment department, obviously. And that was always fun, to go down to the investing department and watch them in action. Okay, for Redington immunization, you have to have 3 conditions met. You need to choose your assets so that the present value of assets equals the present value of the liabilities. You have to choose them in such a way that the duration of the assets equals the duration of the liabilities. And it doesn't matter whether you use Macaulay or modified duration, as long as you're using the same for assets and liabilities, because they're only off by the factor of 1 plus I. And then the third condition is the convexity of the assets has to be greater than the convexity of the liabilities. And if those three conditions are met, then you've immunized your asset portfolio or your asset and liability portfolio from adverse changes due to interest rates. And just, this is more for the definitional types of questions, but when we're talking about interest rates, we're assuming a flat yield curve. In next week's lecture, we'll talk a lot about interest rates, about yield curves, but if you've had Finance 320, then you know the yield curve means that interest rates are a function of time to maturity. And usually when you have a normal yield curve, longer duration has higher interest rates. Well, and that's what typically happens in real life. But for Redington immunization and for full immunization, in other words, for this course, we assume it's a flat yield curve. So a 3-year liability will have the same interest rate as a 5-year liability. And Redington immunization will protect your surplus, but only for relatively small changes in interest rate. It can't be used for large drops or large increases in interest rates. So those are just some things you need to know for the conceptual types of problems. Okay, and then for full immunization, there's a 4th requirement. So all of these 3 have to be met. But in addition, for every liability cash flow, there must be an asset cash flow both before and after. So there has to be an asset cash flow before and after each liability cash flow. And if that happens, then you have full immunization, and that covers any type of interest rate movement, not just small ones. So again, those are the kinds of things, these conditions and the part about interest rates are the conceptual questions that you need to know. I think chapter 15 in the textbook might go over those just definitional type things, conceptual type things. Okay, so now any questions on just the definitions of all these things? All right. Okay, so let's do some examples. So the first 2 examples are cash flow matching. Remember, that's also called dedication, and it's also called absolute matching. And once you see these 2 examples, you'll see that it makes sense. So suppose a company has obligation to pay $1,000 in 1 year and $4,000 in 4 years. They're going to use a dedication strategy using 0 coupon bonds. The yield on the 1-year bond is 8%, and on a 4-year bond is 9%. Now, at first, you might say, well, wait a minute, you just said this only works for flat yield curves. That is for B and C. For Redington immunization and full immunization, you assume that the yield curve is flat. But in dedication, because you're exactly matching the asset cash flows to the liability cash flows, interest rates don't have to be flat. So that condition is only for Redington and full immunization. It just doesn't matter because you're going to have the assets and liabilities exactly match. So the question is, what is the cost of establishing this asset portfolio? So obviously, the only way you're going to exactly match a payment of $1,000 and $4,000 is to buy 2 assets, a 0 coupon bond, a 1-year bond that's $1,000, and a 4-year 0 coupon bond that's $4,000. And there's no other way you can exactly match the assets to the liabilities. And since the question is what's the cost of establishing it, well, it's just the present value of the 1,000 and the present value of the 4,000. And remember, the yield on the 1 year was 8, and the yield on the 4 year was 9. And so the total cost of setting up the portfolio is that 3,700 number. Okay, so that one was pretty obvious. Now the next one is more typical of how the question would be asked on the exam. So now a company has the following projected liability cash flows. So in year 1, they have to pay out 179, then 679, and 144, 3,144, and 824. So here's a picture of the liability cash flows right there. And they have the following available for investment. Now, the first example was 0 coupon bonds, which is very easy. Here, it's coupon bonds. So the company has a 2-year bond with 7% annual coupons, a 4-year bond with 4% annual coupons, and a 5-year bond with 3% annual coupons. Each bond has a par value of 100 and a yield of 5%. The company is using exact cash flow matching to immunize their position, determine the amount of each bond, and determine the cost of establishing the portfolio. Now, again, this is how most of the questions on exact matching, cash flow matching are worded, and they're all solved the same way. And you start at the end and work backwards. So I always write out the liabilities, then I write out what the cash flows from each of those investments are. So here's the cash flow of the 2-year bond. It pays a coupon of 7, so that's the year 1 coupon payment. And then it pays the par value of 100 and the last coupon. So that's the asset cash flows. The 4-year bond has a 4% coupon, so 4, 4, 4, and then it pays the maturity value of 100 plus 4. And the 5-year bond has a 3% coupon, so 3, 3, 3, 3, and 103. Now, in this case, the liabilities, it's going to work out that you're going to get integer values, and that I'm only using this example so you get used to the concept. In general, you're not going to get integer values for the number of bonds. So to solve, you always start at the end and work back to time 0, because if you think about it, we're doing an exact match. So we have to have a combination of these 3 cash flows to exactly equal this set of cash flows. Well, if there's a cash flow at time 5, there's only one possible of our assets that even pays a cash flow at time 5. So that's why it makes sense to start at the end. So if we have a liability of 824, and one of these bonds will pay 103, how many of these bonds do we need? Well, 824 divided by 103, you would need 8 bonds. And so if you looked at the cash flow now, just multiplying by 8, that 103 turns into 24, 24, 24, 24, 824. So we have exactly matched the year 5 cash flow. And now what you do is you subtract this from our original liabilities. So here was our original liabilities. We used 8 of these. So we reduce this string by 8 times that. And here's what it looks like. If you subtract, well, as you see, the 824 canceled with the 824, so we've have no liability remaining at time 5. And now if you subtract the 24 coupons from the liabilities, you'll be left with that. So this string of numbers is just the original liabilities subtracted by the 24s. Okay, so now we need a cash flow at time 4, and the only thing that's available, since we've already used this up, is this one. So for each of these bonds, there's a payment of 104 at time 4, and we have a liability now of 3,120. So how many of these bonds do we need? You do the same process. You need 3,120. Each bond pays 104 at that time, so you need 30 of those bonds. So now you go back and look at what each bond paid, 444, 104. Multiply that by 30, and you get 120, 120, 120, 3120. Now you subtract that from the previously reduced liabilities, and now you'll see that you've completely covered the liability at time 4, and coincidentally, the 120 is also covered by the 120 coupons from the 30 bonds that we just did. So with 30 of the 4-year bonds, we've wiped out the time 4 and time 3 liabilities. We already got rid of the time 5 liabilities with the 5-year bonds. And now we're back to time 2, and luckily we have a 2-year coupon bond. Each coupon paid 107. Each coupon was 7, and so at time 2 it was 107. And so we do the same thing. We have a cash flow of 535. Each bond will pay 107. And so we need 5 of the 2-year bonds. And if you multiply the 2-year bond cash flows by 5, the 7 turns into a 35, the 107 into 535. And now when you subtract it from the remaining liabilities, you get zeros. So that's the process. You start at the end, work back. Now these numbers were chosen, so like I said, the number of bonds comes out to be an integer. That will never happen. So you'll get fractional bonds, but that's okay. So this combination exactly matches the liabilities. So we need 5 of the 2-year bonds, 30 of the 4-year bonds, and 8 of the 5-year bonds. So that was part A of the question. Part B, what is the cost of establishing that portfolio? Well, you just find
I have a quick question.
Sure.
Sorry. So if they had like 2 bonds that had the same time frames, like would that ever happen?
Yes.
Or we had to like choose?
Yes, there are types of questions where, and the ones I send out, you might have a 2-year coupon bond and a 2-year 0 coupon bond. The question would be something like, find the combination that is the minimum cost to the company. So it won't be so there's 50,000 different combinations, but sometimes you have to check 2 or 3. Sometimes it'll say to minimize the cost of the portfolio, or it might say to minimize the par values of the bonds. So yes, that's a good question. Sometimes you'll have to look at a combination where cash flows could come from 2 different bonds.
Thank you.
That was a good question. Now, to find the cost, well, I'll just show you how to do the 2-year, it's just 5 times the present value of each one. So that's just finding the present value. What I did on the other ones is I just used my financial calculator to calculate the price of each of these bonds. Remember, the yield was 5%. So you just find the price of each bond, multiply by 30 and multiply by 8 and add it up. So for part B, the total cost is $4,142. So the rest of them, I mean, the ones you get on this will be done similarly. Like I said, sometimes you'll have to choose them in a way to minimize. So if we're trying to minimize the total cost, and there's 2 possible ways of choosing, say, the 2-year bonds, then unless you can do it by inspection, sometimes you'll have to calculate and see which one is cheaper. Sometimes you can tell by the yield rate. If the yield rate is higher, then the bond is going to be cheaper. Okay, now a couple of examples of Redington immunization, including the shortcut that I would always recommend using to solve these. So remember, 3 things have to be met. The first is the present value of the assets has to equal the present value of the liabilities, and the duration of the assets has to equal the duration of liabilities. The third one about convexity is normally always going to happen, but you might have to check it on some questions. Okay, so in this example, a company is committed to make a payment of $100,000 in 5 years. The company can fund this liability only by purchase of 4-year 0 coupon bond and a 10-year 0 coupon bond, or some number of them. The annual effective for all assets and liabilities is 12%. So remember, for Redington immunization and full immunization, we're assuming a flat yield curve. And so there won't be that the 10-year bond has a higher yield than the 4-year bond. Obviously, we can't do an exact match, right? Our liabilities at time 5, and we have something that has a 0 coupon payment at time 4 and a 0 coupon at time 10. There's nothing at time 5, so there's no way you can do an exact match. So, but for Redington immunization, we need these conditions. The present value of assets is equal to present value of liabilities. So basically, you're going to get 2 equations and 2 unknowns. And with the shortcut method, you can avoid doing simultaneous equations, and I'll show you how. And I do them all this exact same way. Let X equal the percentage as a percentage of its price invested in the 4-year bond. And if there's only 2 choices, then 1 minus X is the percentage invested in the 10-year bond. So it might be 30-70 or 50-50 or 40-60. So that's the shortcut trick. So you don't have to solve simultaneous equations. Now, if there's 3 bonds, you might have to get a little creative, although I don't know if I've seen any like that. Okay, so just say, and it doesn't matter which one you pick for X, but I always pick the shorter duration. So you start with the requirement of the duration. So usually the liability is just a single payment. Remember, the duration of a single payment is just whenever that payment comes in. So the duration of the liability obviously is 5. And remember, to find the duration of a portfolio of assets, it's just a weighted average of the duration of each of the individual ones, where the weight is the percentage of the price. So that's why we let X equal the percentage of the price, because that's the weight you're going to use to do the weighted average. So since the 4-year bond has a duration of 4, because it's a single payment, and X is the percentage, then the duration of the assets is 4 times X plus 10 times 1 minus X, because the duration of the 10-year bond is just 10. And from this, you can solve for X. And this is why you get out of the simultaneous equations. So you set 4X plus 10 times 1 minus X equal to 5. And you get that you want 5/6 of your portfolio to come from the 4-year bond, and therefore 1/6 to come from the 10-year bond. Now we go to the fact that the present value of the assets has to equal the present value of the liabilities. The present value of the liability is just, since the interest rate was 12, it's just 100,000 divided by 1.12 to the 5th. So the liabilities have the 56,000. And so we were trying to look for how much to invest in each of the bonds. And we determined that that percentage of the 4-year is 5/6. So of this price that we're trying to match, since the present value of the assets has to equal 56,742, 5/6 of that is invested in the 4-year bond, and 1/6 is invested in the 10-year bond. And that was what the question was: how much is invested in each one? I think Quint asked me a question that was on, it looked like it was a bond question, but it was really an immunization question, because it says how much of each bond would you need. That sounds like it might be a bond question, but well, it uses bonds, but it's an immunization question. So any questions or comments about the process of doing that? So you always do let X equal the percentage based on the price, and then from that you look at the durations of the assets and set it equal to the duration of liabilities, and then you apply those percentages to the present values. Okay, here is another example of that, a little more complicated. A company has an asset cash flow of 3, at time 3 of A, and an asset cash flow at time 10 of B. It has a liability cash flow of 120,000 at time 6. The company used Reddington immunization to immunize the portfolio based on an annual effective interest rate of 5%. Calculate the ratio of A over B. Okay, so here's a picture of the liability. Again, it's almost always, well, no, the ones you hope for are just a single payment, but it doesn't have to be. And you have 2 assets, one that pays $8 at time 3, so it's a 0 coupon bond, and 2 is a 10-year 0 coupon bond that pays B. And we want to know what is A divided by B. So again, the way you would do this is you'd let X equal the percentage in the 3-year bond, and so 1 minus X is the percentage in the 10-year bond. And because everything is a 0 coupon bond, the duration calculations are easy. Again, it doesn't have to be. You need to know how to calculate duration from the chapter on durations, but you hope it's a zero coupon bond for at least some of it. So in this case, the duration of liabilities is 6. The duration of the assets, well, it's 3 times the percentage of the price, which is X, and the duration of B is 10, and the percentage is 1 minus X. So you get that linear equation again, and you get X is 4/7. Now that we've matched the durations, you match, or you see what the present value of the liability is. The present value of the liabilities is just 120,000 brought back for 6 years, so the 89,545. And we've already determined that the percentage in the 3-year bond is 4/7. And 4/7 times the present value of the liabilities gives you the 51,169, and the 3/7 gives you 38,376. So if the question was like the one for question 3, what's the amount invested in each one, we would be done. But now, just to add a little wrinkle, we need to find out what A and B are. We've got their present values, so it's not hard to find A and B. Now we just bring these times 0 values. Well, you're going to bring the 3-year from time 0 to time 3. So A, the amount at time 3, is just the time 0 value brought forward for 3 years. So it's 59,234. And B is the 38,000 brought forward for 10 years at 5%. So the amount of A divided by the amount of B is 0.9476. So you get questions similar to that. So let me pause to see if you have any questions.
That honestly makes a lot of sense.
Yeah, they're kind of fun, I think.
I agree. Wait till I start doing them, then I'll be panicking.
I've seen solutions, and the way I used to do them was I would set up simultaneous equations. I would have an equation for the present value requirement, an equation for the duration. And you kind of get around that by doing the let X equal the percentage. So,
okay, that's cool then.
Yeah, I recommend that. Now, that was it for the examples. Now, I will call up the questions that I will send out. I'm not going to work on them, but let's review them really quick. I've got to reshare the screen. Where are they? Let's see if I can find them. Okay. Okay. So here's what I'll send out for you guys to work on. So the first one is kind of like question number 2, where there's an obligation to pay $10,000 at the end of 2 years, and they can buy a combination of the 1 year with 4% coupon and a 2 year with a 6% annual coupon. and X is the total cost to exactly match that. So this one you do like question number 2 in the examples. Question 2 here, same kind of a thing, but the question is, what is the par value of the 1-year bond? You have, again, you have a choice of a 1-year and a 2-year. I think the third one was the same, but just to see if you can do it for ones that have semi-annual coupons. The idea is to do it the same way. This one, you see how much is in each of these bonds. Now, then they start getting more into Redington types of immunization, where you got to do the that X percentage thing. I think I have some exact matching intermingled in here, so you do have to be open. It's not just in order. Yeah, so number 5 is back to doing an exact match. And this one is one Tessa asked about. So, well, this one we have a combination. B is a 0 coupon bond and A and C are coupon bonds. So here's an example of one that is a conceptual. Determine which of the following statements is true, and it's got things about what you need to know about Redington immunization, and so on. So,
and is only one of those true?
In this case, yes.
Okay. So I make sure it wasn't like choose all that are true.
No, they do have some like that, but the answers are 1 and 2, 2 and, let's see if I can find one. Well, this is an interesting one. Calculate the absolute value of A minus B. Yeah, so then you have some like this where they're using they're setting up an investment program, and you got to determine what one of the assets pays an amount of X today. What is X? And are the conditions for Redington immunization met? And so there's combinations of values of X. And so this, as you can see, if you get X right, you still might not get the question right unless you know what those conditions are. So another type of way the conceptual comes into play. This is a fun one, number 9. Oh, here's one that we were talking about. So here you have a 2-year 0 coupon bond and a 2-year coupon bond. Calculate the smallest amount the company needs to disperse today to purchase assets that will exactly match the liabilities. So you got to look at a couple combos.
So even if it, like, when they say exactly match, what would be like another case? It would like go over, like why would the company ever want that?
To exactly match?
Well, like they're saying like which situation would exactly match. So what are the other situations possible?
Well, do you do Redington or full? So remember there's 3 types. One is exact matching, and then you'd get questions on that. So here there's going to be 2 ways to exactly match the time 2. One would be the 2-year coupon, and one would be a 2-year 0 coupon. Now, if you remember, if you exactly match the liability cash flows, then you have nothing to worry about, because if the interest rates move, the assets and liabilities are they're going to be identical. So the surplus is always going to be 0.
Okay, thank you.
So here it's fully immunized. So you have to be cognizant of what those requirements are. So I won't give you that one, but here's one where it'll say, determine the combination of zero coupon bonds that has the lowest sum of par value. And there's all sorts of combinations you can choose to match the you're not doing an exact match on this one, you're doing full immunization. So there's a lot of different ways you can combine these, and you need to use logic. It's a logic puzzle, it's a fun one. Logic and what the conditions of fully immunization are to narrow down the combinations that would produce the lowest par amount. And you can see there's several answers. So those are the 11 questions. And so next time I'll start by going over the solutions to those. And then the lecture next week will be, I'm going to stop sharing here, is the last topic we'll be going over, and then we'll do some overall reviewing. But that is interest rates, interest rate swaps, forward rates, spot rates. Again, it's something that I didn't have time to cover in 415. I used to cover it in Finance 444, but it doesn't make sense to take it in that class. So I'll do another lecture like this to go over it, and then I'll send out problems on interest rate derivatives. And then that covers everything except that paper you got to read on how interest rates are determined. It's a practical paper, like what does the Federal Reserve set? What does the Canadian Federal Reserve set? What are T-bills measured in weeks? What do they come in? So that, there's really nothing I can teach. You just got to read that study note and memorize it. And that's kind of what the exams are when you get past the math ones. Oh, a former student of mine he's passed all the ASA exams, and now he's working on the modules that you have to pass. And I talked to him this week, and he said that he's working on one of his modules has asset liability management in it. So he said, I wish I would have paid more attention. I have to go back and figure out duration, all those Reddington immunization and full immunization. So it'll come up again. I'm glad to see that on one of the modules because, like I said, this happens to be something that you work on in practice a lot. And at Pacific Life, you know, that requirement, the duration of the assets and the duration of liabilities, we would meet every month. And we had a rule that the duration of the assets and the duration of liabilities had to be within, I think, 6 months. I mean, we couldn't match it exactly, but we would rebalance the portfolio. We would change our assets around so the duration would stay within 6 months of the duration of liabilities. And we spent hours at those meetings. So it is an important thing to do. And as time passes, the duration of liability is going to change and the duration of the assets. So you're going to get out of balance. So you have to rebalance your assets. You might have to sell some assets and buy different ones because your liability durations are changing with time. So there you have it. 5 minutes to post time. Let's see if I can share the screen with that. Let's see. Let's get to Del Mar.
Four minutes.
Oh boy, can you see that?
Yeah.
Oh, let's watch the first race together. It'll be almost as good. as if I got to take you guys there.
Very cool.
Even
Do you
the
know any
jockeys-
of like?
Oh,
Do
yeah,
you know any of the
this-
horses or jockeys?
Oh yeah, this is my hobby. This and chess. Oh wait, Perry wanted to see the races. He's a big racing fan too. They have platypus races. He's usually in the top couple, 2 or 3. He's a fast one. He just disappears.
He's gotta be.
Everyone's got to wear a mask, as you can see. The jockeys have to wear a mask, just in case the horse. No. So let's see, who did I bet on here? You want to root for my horses. I have numbers 1, 4, and 7.
All right. Red, yellow, and orange.
Yes, very good. Have you ever been there?
I've obviously been to the Del Mar Fair, but not like the race.
But not at
I've
the
never been
racing?
for a race.
I named my son after my favorite racehorse, John.
I love
Henry.
it.
John Henry. He's got a huge picture of John Henry, the horse, that I gave him when he got older. So he didn't hold that against me. My ex-wife did.
That's
Why
good.
would you name our son after a horse?
I love it. There's worse things people name their children after.
Yeah, and John Henry is not bad. But she did draw the line. I could not name my daughter after a horse. So that's all right.
Did you have one picked out?
Oh, I'm sure I did. But Jennifer, something that rhymed with or started with a J like John. So Jennifer is a good one.
Not bad.
Oh, I guess I should have stopped recording. How do I do that?
There's the little